Hello there. Today we're talking about graphing linear equations. So first thing to talk about is the solution. We've already worked with solutions with one variable, like x plus 7 equals 10. That means x equals 3. That's the solution to that equation. But now we've got an ordered pair x, y. So it's got both variables x and y. So it needs to be true for both of them, not just the one variable. So when we had that equation x plus 7 equals 10, there was only one answer. X can only be 3. But for linear equations where there's two variables, well, depending on what you have for x, you're going to have a corresponding y. So there is unlimited numbers of true solutions, true statements when plugging in an ordered pair. So here's our first example. It says, which ordered pair is a solution of the equation 1/2 x plus y equals 3? I'm sure you could think of something if you plugged in a number for x. Half of a number plus another number equals 3, right? You probably could come up with a bunch. Well, here we're going to check all of these four, and every single one has to be checked because more than one can be picked. In fact, it says select all that apply, so chances are there's more than one that can be picked. So I have -2, 4, the ordered pair 2, 3, 0, 4, and 4, 1, and we'll check all. So what you're doing is you're plugging in the -2 for the x variable, because it's an xy ordered pair, and always. And then the 4 goes in for the y, and then you check if it's true. If it's true, then it is a solution. If it's not true, then if it's false, then it's not a solution. So we're plugging in -2 for x and 4 for y. So I have half of -2 plus 4 equals 3. Does it? Question mark. Half of -2 is -1. -1 plus 4 is 3. Is that true? Yes, it is. So that means, that means that A is a solution of this equation. Now we have to check them all. So I'm checking the next one. I'm plugging in 2 for x and 3 for y. Half of 2 is 1 plus 3. Does that equal 3? No, 1 plus 3 does not equal 3. It equals 4. So this is not an ordered pair that's on this line. It's not a solution. Letter C. 0, 4, I plug in 0 for x and 4 for y. So I have half of 0 plus 4. Does that equal 3? Well, half of 0 is 0. 0 plus 4 is 4, and that does not equal 3. So again, no. Last one, I've got the ordered pair 4, 1. So I'm plugging in 4 for x and 1 for y. Half of 4 plus 1 equals 3. Half of 4 is 2. 2 plus 1 is 3. Yes, this is also a solution. So my two solutions, so which ordered pairs are a solution, would be A and D, not just one of them. So you're going to be checking for solutions. Your answer here would be, depending on the way the question is answered, which ordered pairs we just picked these two or selecting them, but maybe it'll be in a different format. Same idea of plugging it in, and you have to get a true statement for it to be a solution or not a solution. All right, now we get into a little bit harder stuff. We are graphing. So we're going to graph, and these are linear functions, hopefully, right? We'll see. Y equals -x plus 3. So the first thing to do is solve for y. Well, there's a check mark there because that's already done. If you look here, y is alone. So y equals -x plus 3 is already solved for y. Yay, step 1 is done. Let's go to step 2. Make a table of values. Pick your own domain. And I wrote 3 numbers in parentheses because I'm just saying, hey, pick 3 numbers. You could pick more, but 3 is a good amount. So I picked -1, 0, and 1. And that's because I want to stay around the origin for my coordinate plane. So when I plug in -1 for x, that goes in the parentheses. Really careful here. I already have a -x. So now I have a -1, which is a +1, plus 3 is +4. So that gave me that ordered pair -1, 4. Worry about that in a minute. The opposite of 0, -0, is still 0, and 0 plus 3 is 3. Another ordered pair. Negative 1 plus 3 is 2. Different sign, subtract. So now I've got my 3 ordered pairs. Step 3 says to plot them on a coordinate plane. You got to draw a coordinate plane. You can keep them really small numbers. I went up to 6 and 5. Maybe just go to 5 on all sides. Make sure you label your axes as X and Y and plot those 3 points. When you're done with that, check it out. Step 4 says connect the points by drawing a line through them. So I'm going to connect the points by drawing a line through them. Use a ruler if you can. Use arrows to indicate that the graph goes on without end. So if you do not extend the whole graph and use arrows, you are not doing 100% of your job here. So super important. All right, and that's it. We were expected to graph. If we relook graph, y equals negative x plus 3. Did we do that? Yes, we did. So our solution is all here. All of this stuff is just fun stuff to make sure we're following our procedure so it makes it easier for us. The really important thing is that we know how to graph. Zooming in a bit because you might need to see this a bit better. All right. Yeah, it should have been more like here and like there. If you're drawing your line a little better than mine. All right, cool. Last thing to talk about is still graphing, but now with this one, we got to use our own domain. We picked these 3 numbers. Sometimes they're going to give you a specific domain. Oh, I just got paper cut. Ouch. All right, so graphing with a specific domain. That's what that says there. Example 3. We're going to graph the equation 4x minus 2y equals 2 with domain x is greater or equal to 3. And then after we're done, we'll identify the range of the function. So step 1, solve for y. Are we already solved for y? Does it say y equals? No, it does not. So I've got to work back on old stuff and solve for y. If you need to rewatch that video, you can do so. So to solve for y, I've got to get y alone. Well, what's in the way? I've got this 4x here. I've got to undo that. That's by subtracting 4x to both sides. And then I'm left within the blue here. Negative 2y equals 2 minus 4x. You can't combine those. Then I divide everything by the number next to y, which is a negative 2. Careful about that. That's a negative 2. And that leaves me with y equals 2 divided by negative 2 is negative 1. A negative divided by a negative is a positive. 4 divided by 2 is 2x. 4x divided by 2 is 2x. So I have y alone now. Y equals is alone. And the other side, I've got negative 1 plus 2x. So that's my input value that I'm putting into the table over here. Step 2, as we saw in the last slide, is make a table of the values, but now we're given a specific domain. X has to be greater or equal to 3. So I picked really simple numbers. They need to be greater or equal to 3. So I picked 3, 4, and 5, which are all greater or equal to 3. So when I plug in 3 into my X, right, let me use a different color. Plug in my 3. I have negative 1 plus 2 times 3. Well, first I do 2 times 3. 2 times 3 is 6. Negative 1 plus 6 is 5. Next I do 2 times 4. 2 times 4 is 8. Negative 1 plus 8 is 7. 2 times 5 is my next x value is 10. Negative 1 plus 10 is 9. So now I have 3 ordered pairs, 3, 5, 4, 7, 5, 9. So step 3 is to plot the points, step 4 was to connect it, but instead of with a line, now we're starting at 3, so it's going to be array. So my first ordered pair is 3. Make a coordinate plane, by the way. Pause the video, make a coordinate plane. Then hit play. My first ordered pair is 3, 5, so that's what you're seeing here. The next one is 4, 7. And then I have 5, 9 right there. Good. Now I need to draw not a line because I'm starting at x equals 3. So here's my starting point and array. So I do have an arrow showing that it goes on forever that way. But it starts at 3. because of this original statement, domain x is greater or equal to 3. If it weren't there, I would not have started there. I would have went on forever, right? I would have extended the line across the entire coordinate plane. Step 5 was identify the range. So let's look at our range value. That's our y values. We've got 5, 7, 9. Could I continue? Right? Could I use different numbers? The only thing I can't use is anything less than 3. So the smallest y value that I'm going to get is the one that matches 3. So the range is my y value starts here at 5 and goes up. So my range is y equals, not equals, but greater or equal to 5. Awesome. We'll practice more of this after.